Swamp Sound's mission statement is to create a plugin with an easy and aesthetic user interface that can be used by beginners. We based our study off of these components. For this experiment, we had a computer set up running our plugin using Juice. We had 4 subjects perform a series of tasks and then asked them some follow-up questions. For our experiment, we gathered both quantitative and qualitative data. Each participant's experiment took about 10 minutes each. For our experiment, 2 participants had experience in music production and the other 2 did not. Our 4 participants consisted of Calvin, who was a math major, Paul, who was a finance major, Carly, who was a psychology major, and Nick, who was getting his master's in business administration. For our tasks, we collected quantitative data consisting of the time it took users to complete a task and their performance. The 5 tasks were 1. To change the reverb to 52, 2. To set elevation to 50%, 3. To change the width levels to its max level, 4. Set location of the sound to be in front of you, and 5. Set the location of the sound to be to the right of you. And then to the right here, we can see a chart with the results that we received from doing these experiments. And in conclusion, users thought the plugin was easy to navigate besides changing the location of the sound. This feature was not fully functional and was not labeled when the experiment was taking place, which is worth noting. This is something Swamp Sound plans to change in the future. For our qualitative results, we gathered data from this experiment that was important to us. The most noticeable discovery we made was that it was difficult for users to set the location of where the sound would be played, even though this was not fully implemented in the experiment. This means it just needs to be labeled better in the future. Overall, the users thought the plugin was aesthetic and user-friendly. The only critiques we received were concerning not having a logo in the plugin and having some empty space.
My name is Cameron, and to start with today, I'm going to be talking about any companies that might be potentially interested in our product. So first of all, this company called Valhalla DSP produces creative audio tools and specifically focuses on pushing the boundaries of current audio technology. So they currently don't support any 3D audio plugins, and their roster could be improved by adding some support of a specific 3D audio plugin similar to ours, so that any users of Valhalla DSP can benefit from including 3D audio in their workflow. Additionally, another company called FabFilter just creates more general purpose audio mixing and mastering tools, and that could also be improved by supporting some level of mixing in 3D audio so that their user base can also just benefit from the general purpose mixing of 3D audio. Additionally, any other companies that support audio plugins, mixing tools, mastering tools, they should consider adding 3D audio in a similar fashion to our plugin, just because any users that might be interested in using 3D audio can then use their software to accomplish that. Past this, if we wanted to look at adding our plugin to an existing system that's basically is looking at some sort of amateur or semi-professional music producer, adding in that into their mixing workflow. So this would allow those producers to have some new creative options for audio production, whether that's creating audio effects or music that would just create some new options creatively, so that would hopefully make their audio production some more interesting to a listener.
Over the course of our project, we had a number of challenges, both anticipated and unanticipated. For anticipated challenges, the actual implementation of 3D audio into our plugin was, as expected, a huge challenge. This was primarily due to having to work within the Juice framework, which our team was largely unfamiliar with. Since we chose not to work within MATLAB, our team had to figure out how to take what we learned in class about 3D audio and apply it to the Juice framework. We ended up solving this challenge through the Juice convolution class, which takes in HRTFs and applies them to audio input. Another anticipated challenge we had was the time constraint of the project and the busyness of all of our lives with other classes and work this semester. For unanticipated challenges, we ran into 2 major ones. The first has to do with the 2D localization circle you can see taking up the right side of our plugin's UI, or on the right side of the screen. This feature of our UI is designed to take in input about where to the front, rear, left, or right of a user a sound is coming from, and to apply that information to our HRTF calculations. It's also designed to control the volume of a sound and how intense that the sound is. Though we planned for the implementation of this circle to be straightforward, since there was no built-in juice module for a 2D slider, our team had to work towards a more complex solution in order for this feature to actually provide meaningful data to our backend. In addition to this feature, another unexpected challenge was the merging of the front and back ends of the project. This was definitely unexpected, but we solved it relatively easily by writing getter and setter functions for the back end of our code and applying them to the front end. Given an additional semester to work on this project, there's a couple of things that we would refine with our existing features, as well as some additional features that we would like to add to overall just improve our plugin and make our project better. To refine existing features, the first thing we would do is make a better GUI. Although our GUI looks pretty appealing and throughout the user study that we've done has had positive results, we would work towards a more complex UI and look at filling in some of the empty space that our UI has, as that was some of the feedback we got from the user study. Additionally, we would work on the back end to have more accurate and clear 3D audio. Though the convolution method that we've been using is effective, we would like to make it more accurate and just clear in general, so that people can just get a better feel for 3D audio rather than the current thing that we're working with. Some additional features we'd like to add with an additional semester would be a full implementation of sound rooms, as we talked about earlier in the project. This was a feature that in development we decided to scrap as it was just too much of a workload and it wasn't the primary focus of our project. So these ideas of sound rooms where users would be able to implement like a studio or like an open field or something like that, we'd like to implement those given an extra semester. We'd also like to implement an option to cater HRTFs to a user. So the ability of a user to put in their information and use more accurate HRTFs so that their 3D audio is catered to them in this plugin. We'd also like to think about using just better 3D audio technology than what we have. Although the 3D audio functions that we've been using do work, it would be interesting to see if we can incorporate something like the Bach Lab software that has a lot more just technology backing the 3D audio and can create a more realistic and just better sound in general. So that pretty much concludes the future steps for an extra semester, but there's definitely some more steps that we would take given unlimited time and resources. Given unlimited time and resources, we would work to develop both the back end and front end over again. So for the back end, we would, instead of using the Juice framework for convolution, we would develop our own original digital signal processing. So I talked a little bit about convolution earlier, but basically what it does currently is it takes Juice's built-in convolution class, which is a part of its digital signal processing, and it applies our HRTF function to it to merge the two and create the illusion of 3D space in the audio. The problem with this is it's very generalized in the Juice framework, and it's designed to be used to create different things with different functions. So a lot of people use it for reverb, and we just use that convolution method for our 3D audio. The issue with this is it's too generalized to provide the clearest form of 3D audio that would be possible, even with the right HRTFs. So what we would do, given unlimited time and resources, is write our own digital signal processing library, which would basically take in the HRTFs from the beginning and create that 3D sound using a custom convolution catered directly to 3D audio. This would replace the Juice convolution and make our backend just a lot more clear and a lot just better on the 3D audio side of things. For the front end, we went a little ambitious here and thought that it would be really cool to implement a augmented reality using VR, which would basically create just an entire room where people could explore and listen to 3D audio. So someone could literally like put on a VR headset and feel like they're in a studio, combined with the back end where they hear the audio from this instrument over to the left and this instrument over to the right, and they could be in the studio while all that's happening virtually. And so that's the changes we would make to the front end. We just create that entire VR-based space. We completely overhaul the UI that we have right now for a virtual reality option.
My name is Joseph Dorsey, and I'll be going over the development progress. So this is the demo that we have for you today. This is our plugin actually loaded into a DAW that you can see behind you. And so far we've implemented the elevation slider here, the mix knob, the reverb knob, and we've even created a quick little debug panel here that allows us to see what HRTF we have access or activated, and also two text boxes that allow us to choose the individual HRTF on our own through numerical input. And this elevation slider does work, and you can see it updating the HRTF right now. And then we've also implemented default values for both the elevation, the mix, and the reverb knobs. What we haven't implemented yet is this circle here, which will control the azimuth and the distance of the sound to or from the user. So that's what we have currently implemented. So now a little bit about how we developed it. We split up the coding into the front end and the back end, the front end being the GUI, and then the back end being all of the mathematical operations necessary to make the 3D audio and to store it in any meaningful way. So yeah, so far in the back end we have implemented all of the data structures to house all of the HRTFs and reverb impulses. We've also implemented all of the necessary setters and getters for the front end, so that way we can seamlessly mesh the two. And we did connect the two, the elevation and the mix and the reverb, a couple of days ago. So we're just waiting to get the circle connected and up and running. But we hope to have that done pretty soon. So a couple of things that we're going to look into doing before the final deliverable. For the front end, we hope to have a few more numbers, just some minor graphical improvements, numbers like this and the reverb for maybe the elevation and the circle here. We're just looking at what looks best, and maybe some improvements on how some of this stuff functions, like in terms of the sliders and knobs, and of course the circle, all in terms of the UI, not necessarily with the back end. We also want to have implemented our logo down here in the bottom, and then a couple of additional features we wish to implement, perhaps a debug button that allows us to toggle the viewability of this panel here, and then we're looking into getting a menu to select different types of reverbs, because the back end already has implemented several reverb impulses that we can use. So we want to connect that with the front end. And then for the back end, we want to look into the way in which we're implementing the 3D audio. Right now we're using Juice's built-in convolution functions and classes to implement the MIT HRTFs into our plugin. So we want to look at how we're doing that, and if we can improve the way that we're doing that to make it more efficient. And we also want to look into, MIT offers several variants of their HRTF files. We're using a particular variant right now, but we want to experiment with the others to see which one truly is best for this plugin. We also want to look into adding new features in the back end, like volume adjustment, which will become crucial when we finally get this circle up and running, and then perhaps a dry knob to control exactly how much of the sound you're hearing from the plugin that's unaffected by the 3D audio aspect of the plugin and how much you're hearing that is, all in the name of producing a better 3D audio effect. So again, we're just trying to produce the best 3D audio effect we can. In terms of actually seeing audio run through the plugin, I'm not going to try to play that in this video. Perhaps we'll include some snippets for you guys to view at the end. So that's all I have for you.